15, it's asking us to solve for x, and they're giving you SM and HM. So when I'm looking at it, SM is the whole thing, HM is the centroid decide. So, right, so that way I know that it's the setup would be centroid decide equals 1/3 the whole thing. All right? Correct. Now, before I go that far, well, we'll fill this in first. All right, so we'll do that. So excuse me. Centroid decide is the HM, so that was the 2x minus 2. The whole thing was the 2x plus 2. So at this point, you could have done one of two things. Use your calculator with the fraction bar and just mathed it with fractions. It'll work. That's why we have calculators, not using phones. Phones are great for quick little math things. In math, you need a calculator, all right? So you could do all of this in terms of fractions, it works. Or, how do you undo multiplying by a fraction? You multiply by its reciprocal. Remember, if I wanted to undo multiplying by 1/3, I'd multiply both sides by 3. If I multiply both sides by 3, it gets rid of the fraction. You've done that when you did halfsies. You've done that when you had 1/2 of x equaling 8. How do you undo multiplying by a half? You multiply it by 2. You multiply both sides by 2. It's the exact same thing, except you're multiplying by 3. That's it. So then you get 6x minus 6 is 2x plus 2. Okay? Subtract 2x, add the 6, you get 4x is 8. You get 2. To undo multiplying by a fraction, you multiply by its reciprocal. Okay? That's how that works. That's just a simple little algebra trick that you guys have all seen, but forgot. Okay? The other one was what, 18? Oh, Dan, what do you got? I'm just because that's the rule from yesterday.
Oh. But that's just oh.
There's 4 of them. Do you have those written down?
I have that one written down.
Maybe.
Oh, I do have one. I do have one.
Pedro, which one was it? You said 18?
18.
That's a -6, right? I'm just going to write it as 2x minus 6. Are we okay with that? So it says find x if ZW is that and WF is the other part. So you have centroid decide and vertex to centroid. Okay? You have centroid decide and vertex to centroid. So that's when you use one of those two. So it's up to you which one you want to use. I would usually do the double the centroid decide equal the other one because then I don't have to deal with the halfsy. Okay. So if I double the centroid decide, it equals vertex to centroid. Fill in the blanks. Centroid decide is the WF, so double 2x minus 9 has to equal the 2x minus 6. Okay. When I double that, I'm going to get 4x minus 18 is 2x minus 6. Excuse me. Subtract 2x, add the 18, we get 2x is 12. You get 6. Once again, it is so important that you understand these 4 scenarios. You kind of have to know them. Okay? And that's why we wrote them up like that. That's why we wrote them out. You can look at them and go from there. Okay. You said 24, was it?
Yeah.
All right, so let's see here. We have HL, and HB, which is the whole thing. So that is our vertex to centroid, and then we have the whole thing. So we write it out. Vertex to centroid is 2/3 the whole thing. Okay? Fill in the blanks of what you know. Vertex to centroid is HL, 3x plus 1 is 2/3. The whole thing is 7x minus 1. Once again, you can use your calculator to do this. It does the math for you. Or, like we did before, instead of multiplying, undoing 1/3, we multiply by the reciprocal. What's the reciprocal of 1/3? It was 3. What's the reciprocal of 2/3? 3/2. So if I multiply both sides by 3/2, I'm still going to wind up, no matter what I do, with either a decimal or a fraction. It's okay. All right? I get 9/2 x plus 3/2 is 7x minus 1. 9 over 2 is 4.5, isn't it? What's bigger, 4.5 or 7? 7. So what's 7 minus 4.5? 2.5. What's 1.5 plus 1? What's x?
Okay.
Okay, you get 1. And then it said find HL. So what's 3 times 1? Add 1, you get 1. Okay. Also, like I said, you have a calculator. If you type in 2/3 of 7, 3x plus 1 was 2/3. Was it minus 1, guys? Okay. So if you have all of this and you want to use the calculator, it does this for you. 2/3 times 7 equals 14/3. 2/3 times -1 is -2/3. Now, what do you think? Is 14/3 bigger or smaller than 3? It's bigger. So now we have that 14/3, which means we'd have to subtract the 3 to it. So it's already here. You hit -3, and it gives you this, 5/3. Here I have 1, and I have to add to it the 2/3. See how I'm just pressing buttons in my calculator? If I know how to just move equations, it does it. 5/3 times what equals 5/3? 1. Use your calculator, guys. Don't use your phone. That won't help you. It is the same, yeah. And that's the idea. It works either way. That's why if you have a calculator, it just makes your life easier because it does it for you.
But if you know it, it'll make your life easier.
Ding, 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 ding.
Yeah, don't forget that.
It's perfect. It's fine. Yep, because then you multiply everything by 3. It's a hell of a great idea. It works. Yep, that works out very well. That is a very good idea. Okay. What's the other one? 30? Not a problem. Well, not a problem for me, shall we say. Or at least not yet. At least say, oh. I'm being very modest.
No, there's one.
we have NJ and NK. NJ is a side, NK is the part. Is it point N the midpoint? Yep. So you have to double the one to equal the whole. You have to double the NK to equal the whole thing because N is the midpoint. Remember, medians connect vertices to midpoints. That's the vocab we have to understand. So I have to double x over 4 to equal 2x minus 3 over 4. So if you double 1/4, you get 1/2. So this becomes x over 2. And now this looks exactly like the problem we did at the end of class yesterday on the sheet, where you had fraction equal fraction. And that's the reason why I gave the example, because you knew that you're going to have to do some cross multiplying. So if you cross multiply, you get 4x equals, what is that? 2, oops, write that down. 2 times the 2x minus 3. And then I get 4x is 4x minus 6, and I get 0 for -6. Did I write something down wrong? NK. No, I know. I just want to see my doublets. No, this is that's actually no solution. I didn't give you an answer on that one on 30. Did you guys look at the answer at the back of it at the end on the calendar?
I was right.
What did I screw up? Did I write something down wrong?
I told you.
I double NK has to equal the whole. It's 1/2. 4x minus 6. 4x. Yeah, something's wrong on that one. That can't work. Yeah, no kidding, right? What do you got? You can't right off the bat though. That's the problem. Because this is NK is half of this. You can't. Yeah. I wonder. Oh, it is NJ. I wrote K. I looked at it as KN. You are. Yeah. I apologize, guys. I just realized NJ. I'm sorry. I just noticed that. I thought it was the whole thing. My bad. These two are equal. I'm sorry. Those two are equal. Yes, those two are equal. I made a mistake. I read the letters wrong. I'm allowed to make a mistake every once in a while, right?
Yeah, right.
I'm sorry. Don't. Remember, I'm sorry. I mean, you're giving me the. I screw up. I'm human. Sorry, these two would be equal. Just cross multiply. Would you get 3/2? Or 3/4? Yeah. 7.75 to the 1 time. Okay. I'm sorry. Sure. Hopefully I don't screw it up. That could be bad. Oh well. It happens. All right, so let's see what parts we have here. Find ZD if TZ and TD. Okay, so this one is, we have to find the centroid to side after we use vertex to centroid and the whole. So this one has your vertex to centroid is 2/3 the whole. Okay. TZ's vertex centroid, the whole thing is TD. So let's see here, we have 2x minus 6 is 2/3 x plus 9. Now this one's going to work out rather nicely when we multiply by the reciprocal. Get rid of the fraction. So you're going to multiply both sides by 3/2. And now when you distribute in the 3/2 into the 2, it's pretty easy. 3 times 2 is 6. 6 divided by 2 is 3, so this becomes 3x. And then 3 halves of 6 is 9. Add 9, subtract x. You get x is 9, but it asks you to do a bunch of junk with it. Subtract x, add 9. Okay. And then it wanted us to figure out the small chunk, so we have to substitute in here. 2 times 9 is 18, subtract 6 is 12. So that gives me the TZ is 12, and this should be half of it at 6.
Alright.
Okay. Sure. Yeah. I see. Yeah, that's fine.
Okay.
So here's the thing. You did something wrong with tests. What I would like to do, you start testing it. You map it. You did everything. It happens. Yep, then everything will clean up.
Yeah.
But yeah, I like your strategy of doing that. Get rid of 8 by multiply by 3, so that you just get rid of it. So today, what I wanted to do today was originally I wanted to go through 5, 6, and 5, 7, but I decided that when we talked with this thrower and with Montana a little bit about what all is in those 2 sections about what we really need to worry about. It's about 4 minutes of instruction. I think we're going to be okay if we pull off and do that until, tomorrow, when we do the class review stuff. Yeah. So, one of the things that I like to do, yes, I'm set. One of the things I like to do with these is kind of go through to make sure we know what segment stuff you're working with. All right. So let's see here. I think. Oh, I forgot to scan this one to me. All right. Now, as we go through stuff like this, I'm going to give you guys 2 different sheets. One of them has a really nice diagram as far as what things are. It wasn't that bad. We need to drop it. I don't know. We'll see how it goes. Alright, so, ladies and gentlemen, back to this. As I was saying, a lot of times with this chapter, it's the vocab of knowing what you're looking at. And what I found was this last sheet that came back to you has the 4 pictures on the front. These little, it's one of those guys. The 4 pictures up on the front there show us basically the things we've looked at. 3 of them are the ones that we've done math with. That was the centroid, the circumcenter, and the incenter. The orthocenter was the one we just used as a definition. So remember, when we did centroid stuff, that's everything that was here on our whiteboard. So maybe a good idea as a reference guide as we're going through these things to put your 4 rules in that top spot. The one to the right of that, the circumcenter, if you recall, the circumcenter was when you had your triangle. The circumcenter is where all the perpendicular bisectors intersected. So when you had a perpendicular bisector, forget my awesome drawing here. The point where the perpendicular bisectors meet was the circumcenter. And do you remember what segment was created that was congruent between all 3 of them? When you had the circumcenter. That's what we did Monday, I think. Remember that was the point to vertex? Point to vertex in this one were all the same. This is the circumcenter. The circumcenter has the point to vertex. Now, it says that in the definition, but it's not marked in that diagram. So it wouldn't be a bad idea in that diagram in the top right corner to draw from that point to the vertices and label them congruent. This is how you're going to be able to distinguish what you're working with, because you have to know which one you're looking at. The in-center was the angle bisectors. And remember, the way that we were able to tell that is because you saw the angles marked. Excuse me. Oh, excuse me. And then this part, it was the point to sides were congruent. So in this one, you had those 3 spots would be the same. Okay? Again, the idea of these diagrams were just generic enough to help you fill in a little bit more. That way you have a reference guide in front of you as to which one you're working with. Okay? And then the last one that we looked at was the orthocenter. The orthocenter was just the altitudes. Okay, that's just where the altitudes means. It just means where if you're perpendicular to a side and you're moving towards the inside of the triangle. Really, that's kind of all there was to it. Okay, so again, mark those pictures. Fill in a little bit of the information that we've done, because that's kind of what you need to know to be able to do the test then on Friday. Okay. Like I said, this is a super, super fast chapter. Also, the stuff that we talked about with 5-6, remember how we did our hands opening it up? The bigger the angle, what happened to the side across from it? The bigger the angle, the bigger the side. That's basically 5-6, 5-7. So you've kind of already seen all that, so it's not a big deal. The only other part to it is range, and that's literally takes 2 seconds to talk. Okay? So, with that being said, let's flip to...
Okay, so this one was at the top, and this one was at the top, on the bottom left, and this one was at the top right? Yes, sir. Gotta make sure.
So, let's see. I'm I'm back at the one page now that has all the multiple choice. Okay? I'm at the page that has all the multiple choice. By using what we know now, right? So the centroid remembers where medians intersect. All right? Excuse me. Now, on 1, what do you think? I think it's
Where's one over?
I think it's A.
I think it's A.
It's either A or B.
if it's it doesn't matter if it's straight through the middle.
It's a bisector, that's all it
If it's a bisector, if it's a perpendicular bisector, remember that does 2 things. It's perpendicular and it bisects. Do you see tick marks on the bisector? Which means it is the
Hey, where's it? What is it?
the altitude.
Oh.
Okay. Remember, the I wanted to tell her to take the bet, but gambling. Yeah. So remember, altitude just means you're perpendicular. That's all it means. All right. There's no markings, otherwise it would have been marked. All right. That's the idea. You have to understand what you're looking at. 2. What's 2 then?
Good.
A.
I think it's A.
Once again, what does a perpendicular bisector do? It does 2 things. It's perpendicular and it bisects. Do you see a right angle?
No. No.
C.
Right.
These are all the words I've been telling you we had to know this entire chapter.
is. That was
No.
That's the.
Now, what do you got on 3?
A.
You right?
What's 4?
B.
Okay. All right. Have arguments within your own brains and try the multiple choice in the next pieces. For the 5 through 11 real quick. We'll check them out. It should only take a couple minutes. You should know the words. Gotta know the words. You should know the words. Gotta know the words. Come on, guys. Altitudes meet where?
Centroid.
Orthocenter. I remember altitudes is the height. Remember how we talked about yesterday? What do orthodontists do? They check straighten your teeth, right? Altitudes straight. They go straight up and down. You stand up straight. It's a dumb way to think about it. That's the only thing I can think of. Okay.
Right.
Yes.
That's what you said yesterday.
Yeah. Medians intersect where? Centroid. Perpendicular bisectors meet where? Angle bisectors are in center. What's equidistant from the vertices? Good. What's equidistant from the sides? Sides. Sides is the in-center.
Oh, I had that right.
Sides is the in-center. Equidistant from the sides are the in-center. Remember?
I had that right. I just looked at
And then the last one. Now, we didn't really talk about the 2-to-1 ratio, but which one do you have to double to get to the other one? Which one do you have to take half to get the other one?
Centroid.
That's the idea of what's called a 2-to-1 ratio. We just didn't say it that way. So I wouldn't ask you in a ratio format, sir. The equidistant from the vertices is the circumcenter.
Yeah.
The in-center, yeah. Remember the in-center is where the angle bisectors meet, and they're always equidistant to the sides. Because remember, the circle can go in the center, and if it touches all the sides, it means those side pieces are all radii, which means it works. Okay. Now on the back, it's your friend, the pictures. Which means you should be able to identify which is which. Now I would say one thing, for number 20 and 23, I wouldn't ask you those two. Even 21 looks a little weird. But what's 22 have to be? It's an in-center, right? Yeah, because the circle can be in the center of the triangle. So basically, I wouldn't ask you anything too far-fetched of those diagrams of which one's which, but you should be able to pick those things apart. Right?
Just too late.
No, I believe so. Yes, because it's the perpendicular. No, I'm sorry. I'm sorry. No, that's the ortho. 20 is the ortho. Oh, wait, I'm sorry. You were looking at this one. Yes. Yeah. That would be that's the circle. Yes, because the circle goes around. Because remember where the vertices go? The vertices go out farthest, which means the circle would go all the way. Wow, I was really badly drawn from my part. Not even remotely close to being in the right spot. But yeah. You see what I mean by having to know what the vocab is to understand what parts you're working with now?
Yeah, because of the multiple choice.
Not just because of that, because when you're looking at pictures, depending on what stuff is given to you, you have to understand what you can do. That's where a lot of the stuff is kind of missed. Let's roll through this real quick. Yes, sir. What's that? No, I got other stuff. I just want this is some quick review to roll through. 12. What is 12 going to be? Is it a centroid, an in-center, or a circumcenter? Centroid. It's a centroid. If it was a circumcenter, what other pieces would it have to have? You have to have perpendicular there, okay? All right. 13 is the in-center, because just the angles, okay? On 14, it's the what's congruent? Point to sides. I'm sorry, point to vertex. So that's got to be a circumcenter. Okay.
Yeah.
Well, remember, there's 3 of them that you got to understand what parts go where. Okay, that's the idea here. This is the big idea. 15, you have perpendicular bisectors, which means it's the circumcenter. Good. In 16, you're just perpendicular, which means you are the.
I wrote centroid, but I was like, yes.
Well, do we see any right angles on a centroid? No, do you see any sides being bisected on a centroid? No. All we have is that we are drawn to be perpendicular to the side. If you're just perpendicular to a side without any other tick marks, you have to be the orthocenter. Because those are altitudes. It's the orthocenter. If you look at 17, 17 is perpendicular and equidistant to the sides. That's the incenter. Okay, that's the incenter. 18's easy. What's 18 have to be? The only thing that's shown are the angles being bisected, which means it has to be the incenter. What's 19 then? Yeah, that's your circumcenter. And then, like I said, what's that? That's your circumcenter. It's perpendicular bisectors. 17 was the incenter, yeah. I'm sorry, hold on, I was just looking. 20 would also be an orthocenter, yes. But that gets a little bit too crazy of a picture. I wouldn't ask one like that. I wouldn't give you guys things that go outside a triangle, so you don't have to worry about looking at number 20, 21. 22 and 23 you could figure out because the circle's in the center and the other one's on the outside, so that means it's the circumcenter, so that's pretty straightforward. I know as far as time-wise though, the other piece I wanted to get to us here today, this will probably take us a day or so to get through, which is fine. And again, this has got all the different points of concurrency to them. We'll go back through that other side that we haven't done yet. We'll do that one again tomorrow, no big deal. Yep. Now, I know that there's a lot on this one here, but, hey, it's all vocab. On this sheet, so here, heads up. Yeah. On page 1, you should be able to do 1 through 7. Page 2, you should be able to do all. And page 3. So I want you to get through those parts for today. And we will continue going through this stuff tomorrow. All right? Basically, those page 2 and page 3, they're 4 problems, guys. They're just little multiple parts to it. All right? The other ones have a little bit of the vocab. And this is the kind of stuff that I want you guys to be able to recognize and be able to set up, solve through, so that when we do have our test on Friday, you won't have too much of an issue. That's the idea. Understanding the vocab. If you get the vocab, everything else falls into place. Yeah, which one does it read at? Good times had by all already.
Oh, my knee just cracked.